and module. Couple of questions here left, or almost done. Mm-hmm. Most of it is done. Okay. कुछ डाउट्स आया मॉड्यूल में? कोई डाउट नहीं? या एनी आंसर you feel is not correct or something? कर दिया है? ओके, चलो जल्दी से इसको कंप्लीट कर लेते हैं. आई विल गिव यू वर्कशीट आफ्टर दैट. पेन कहाँ गया? ओके, मोशन अंडर ग्रेविटी के तो काफी सारे क्वेश्चंस विजिट कर लिए होगे तुमने, है ना? फाइन. ओके, दिस वन, solve the question. If the body is being released from a moving body, gains the same velocity as that of the moving body, right? क्योंकि रिलीज किया गया है, that means remains at rest with respect to the moving body. इसका मतलब ये हुआ कि जो बॉल ड्रॉप हुआ है विथ रिस्पेक्ट टू बलून, इट हैड अ वेलोसिटी ऑफ 7 मीटर पर सेकेंड एज सीन बाय अ ग्राउंड ऑब्जर्वर. ओके, सो इट्स जस्ट लाइक 7 मीटर पर सेकेंड से एक बॉल प्रोजेक्टेड है अपवर्ड डायरेक्शन में, एंड दिस इज द मोशन इट इज अंडरगोइंग, राइट? तुमसे पूछ रहा है कि हाउ लॉन्ग विल इट टेक फॉर इट टू रीच ऑन द ग्राउंड. कर लोगे इसको? दिस इज वेरी सिमिलर टू द फर्स्ट क्वेश्चन दैट वी डिड. इसका आंसर बताओ. रिलेशन बिटवीन एच यू एंड एन इज. So time taken by it to reach the highest point of its path, time taken by particle to hit the ground is n times the time taken to reach the highest point. Time taken by it to reach the highest point is u by g. So n times u by g is the total time taken. So what's the correct relation here? अब since they have not given okay, g h ये सब के फॉर्म में दिया हुआ है, तो कैन आई से कि यहाँ से जैसे ये ऊपर जा रहा है, with what velocity it is going to hit on the surface? Under root u square plus 2gh, correct? दिस इज द वेलोसिटी विद विच इट हिट्स द सरफेस, है ना? तो अब हम यहाँ पे क्या लिख सकते हैं कि टाइम टेकन टू रीच द हाईएस्ट पॉइंट ऑफ इट्स ट्रैजेक्टरी इज u by g. सो n टाइम्स u by g will be equal to how much? The difference in the velocities divided by g, है ना? फर्स्ट इक्वेशन से डेल्टा vy divided by g, what value we are going to get here? They will get added, no, क्योंकि opposite direction में. तो u plus u square plus 2gh upon g. This is the relation you are getting. इसी को रीअरेंज करके आ जाएगा आंसर, करेक्ट? सो व्हाट आंसर यू आर गेटिंग फाइनली? चेक करके बताओ. जी इज गेटिंग कैंसिल्ड आउट. यू को तुम उधर ले लो, स्क्वायर कर दो. थिंक यू विल गेट द आंसर फ्रॉम देयर. क्या आ जाएगा ये? n माइनस वन टाइम्स यू इज इक्वल टू अंडर रूट यू स्क्वायर प्लस 2gh. और अगर दोनों तरफ स्क्वायर कर दिया तो यू विल बी गेटिंग दिस एज n माइनस वन यू स्क्वायर होल स्क्वायर. दिस इज इक्वल टू यू स्क्वायर प्लस 2gh. So final option for this is किससे मैच कर रहा है ये? ए, n square minus 2n, 1 u square will get cancelled out, right? तो ये आ जाएगा अपना आंसर. ट्राई करो इसको. अच्छा, मॉड्यूल वाला क्वेश्चन है. हैव यू डन दिस? ड्रॉप फ्रॉम द टॉप ऑफ द टावर. और ये बोल रहा है कि एक विंडो को क्रॉस करता है इतने टाइम में, 0.125 सेकेंड्स में. द बॉल कंटिन्यूज टू फॉल, मेक्स अ completely elastic collision with sidewalk and reappears at the bottom of the window at 2 seconds after passing its way down. How tall the building is? ट्राई करो इसको, फाइंड आउट द आंसर. रीअपियरिंग एट 2 सेकेंड्स मीन्स कि बॉटम ऑफ द विंडो से 1 सेकेंड नीचे गया होगा, 1 सेकेंड ऊपर आया होगा. So it fell for 1 second and then came back in 1 second. And the distance that it covers is 120 centimeter in 0.125 seconds. आ गया. एक तो इसका तरीका ये हो सकता है कि यहाँ पे स्पीड अगर u है, यहाँ पे v है, कैन आई से u प्लस v बाई 2 मल्टीप्लाइड बाई 0.125 इज इक्वल टू 1.2. ठीक है. इससे हमको ये u और v का रिलेशनशिप मिल जाएगा कुछ. वी आर गेटिंग u प्लस v इज इक्वल टू 2.4 बाई 0.125. ठीक है. एंड v इन टर्म्स ऑफ u यू कैन वेरी वेल राइट, नो. इसको बहुत इजीली लिख सकते हो u को, v को u के टर्म्स में. यू विल गेट द इनिशियल स्पीड, आई मीन एट द स्टार्ट ऑफ द विंडो. फाइनल स्पीड भी आ जाएगा एट द बॉटम ऑफ द विंडो. और एक टाइम उस 1 सेकेंड से उसको लग रहा है नीचे हिट करने में. तो आई बिलीव यू कैन फाइंड आउट द वैल्यू. This is one way of doing it. Otherwise, what you can do is displacement from top of the tower till that point is half gt square, and from top of the tower till this point is half g t minus 0.125 का होल स्क्वायर. ठीक है, उससे तुम्हारा t आ जाएगा. वंस यू गेट द वैल्यू ऑफ t, उसके बाद तुम क्या बोलोगे, t में फर्दर 1 सेकेंड अगर ऐड कर दो, सॉरी 1.125 सेकेंड अगर ऐड कर दो, तो यू विल बी गेटिंग द टोटल टाइम ऑफ द फ्लाइट. सो अंडर रूट 2h/g से इक्वेट करके वहां से आंसर निकाल सकते हो. दैट इज अनदर वे ऑफ डूइंग इट. गॉट इट? गॉट द आंसर? कितना आया? इससे कितना आ जाता है? ये आ जाएगा तुम्हारा 1/8. सो 1/8 दैट मीन्स 2.4 into 8. हाउ मच इट इज कमिंग? 19.2. So now what we can do is u plus u plus 5 multiplied by 0.125. This is equal to 19.2. करेक्ट. और यहाँ से u निकाल लेंगे. कितना आ जाता है ये? 2u is equal to 0.125 into 5 is how much? 4 आ जाएगा तुम्हारे 0.5, तो 0.625. तो 19.2 minus 0.625. How much is the value coming out? U का 18.5. 55 something like this divided by 2. This is the velocity at this point. तो यहाँ से यहाँ तक का टाइम मेरे को मिल जाएगा ना. gt is the value of u. टाइम मिल गया तो टोटल टाइम ऑफ फ्लाइट भी मिल जाएगा इसका, एंड दैट विल बी इक्वल टू अंडर रूट 2h/g. यू विल गेट द आंसर फ्रॉम देयर. ठीक है, कैलकुलेशन करो. So velocity v is 9.275 and नहीं 9.275 तो u आएगा, और v you can say that will be equal to 0.625. अगर ऐड कर देंगे तो कितना आ जाएगा? 0.625 will be 9.9 approximately. So 9.9 meter per second is the value of velocity when it is reaching here. ठीक है, तो एक्चुअली अगर g को 9.9 से अप्रोक्सीमेट करें तो दिस इज गोइंग टू बी 1 सेकेंड. नो, दिस टोटल टाइम इज 1 सेकेंड. तो 1 सेकेंड 1 सेकेंड 2 सेकेंड हो गया, एंड दैट इज इक्वल टू अप्रोक्सीमेट वैल्यू मैं बता रहा हूँ यहाँ पे just to avoid the calculation. This is equal to 2. So if we square and both the sides, we will be getting 2h/g is equal to 4, which means h is equal to 2g. Okay, and that's approximately equal to how much? 9.9 into 2, 19.8 जैसा. ठीक है, तो 19.8 मीटर विल बी द हाइट ऑफ द टावर. दिस इज वन वे ऑफ डूइंग इट. अदरवाइज टाइम से तुम कर सकते थे हाफ जी टी स्क्वायर, हाफ जी टी प्लस 0.125 का होल स्क्वायर. डिफरेंस ऑफ दोज टू विल बी 120 सेंटीमीटर. गेट द वैल्यू ऑफ टी एंड आफ्टर दैट ऐड करके टोटल टाइम निकाल लो, उसको √2h/g से इक्वेट कर दो. ठीक है, क्लियर? फाइन. Particle dropped from a certain height, the time taken by it to fall through the successive distances of 1 meter each. Obviously टाइम जो है बढ़ता जाए, मतलब टाइम डिक्रीज होता जाएगा, राइट? सो दिस शुड बी द आंसर. आई बिलीव यू अंडरस्टैंड दिस. √1, √2 माइनस √1, √3 माइनस √1, ऐसे सक्सेसिवली बढ़ेगा ये. अच्छा, व्हाट कैन यू से अबाउट द डिस्टेंसेस देन? डिस्टेंसेस के बारे में क्या बोलोगे? जैसे यहाँ से एक बॉल को ड्रॉप किया तुमने, सो फॉर द फर्स्ट सेकेंड और फर्स्ट डेल्टा टी इनफैक्ट, अगर इसका डिस्टेंस अगर s है तो नेक्स्ट डेल्टा टी में कितना कवर करेगा ये? 3s. नेक्स्ट डेल्टा टी में कितना कवर करेगा ये? 5s. राइट, राइट. दिस इज हाउ द रेशियो विल बी. सो डिस्टेंसेस विल बी इन द रेशियो 1:3:5:2. इस तरह से जाएगा ये. तो आई बिलीव दिस इज क्लियर. हाइट के बारे में पूछ रहा है ये. Ball is projected. I think this question we have done already. T1 T2 वाला. Maximum height from the point of projection. देखो ये. Particle projected from upward from the top of a tower. Its speed at h distance below is twice the speed at s distance above the point of projection. So you understand how to relate u with this h, right? और निकाल लो उसको, इक्वेट कर दो 2 से, उससे h आ जाएगा. Is this what they are saying? Velocity h height below will be under root u square plus 2gh. H height above will be under root u square minus 2gh. And this is how they are related. If we square both sides, will be getting u square plus 2gh is equal to 4 times u square minus 2gh. ठीक है. अब h से वो relate हो जाएगा u का value. And then after that all you need to do is h max निकाल दो यहाँ पे. So are we getting 3u square is equal to 9gh? नहीं, 10gh. 8 plus 2, हाँ 10gh हो जाएगा. So which means u square upon 2g is how much? 5h by 3, correct? सही है ना? u square upon 2g is the value of maximum height, which is 5h by 3. ये वाला भी कर लोगे. It is very similar to that balloon वाला problem. Rocket is fired vertically, ascends with a constant vertical acceleration this much for 30 seconds. So 30 seconds तक it was accelerated in upward direction. Now when they say acceleration of 19.6, doesn't mean that you are going to take g also. Overall acceleration का बात कर रहा है. ठीक है, 30 seconds तक ये जाता है ऊपर, and after that what happens? Fuel is completely consumed. So maximum height altitude reached they are asking. तो यहाँ तक 30 seconds तक तो accelerated था. After that it will be in free fall motion. Okay. तो ये एक maximum altitude तक जाएगा and then it will fall down. It is again similar to particle projected from top of a tower. ठीक है, हो जाएगा ये वाला question. This I believe is from module. इसको देख लिया ना. Two particles are dropped from balloon accelerating upward. I think this also you can do. Distance between two particles 1 second, 1.5 second after the second particle is dropped. कर लोगे इसको तो बहुत easy सा हो गया. ठीक है. Write on one more question. लिखो. A particle is dropped from top of a tower. A particle is dropped from top of a tower. When it has fallen a distance of x, when it has fallen a distance of x, when it has fallen a distance of x, the other particle was released. The other particle was released from a distance y below the top. From a distance y below the top. From a distance y below the top. If both of them land simultaneously on the ground, if both of them lands simultaneously on the ground, if both of them lands simultaneously on the ground, determine the height of the tower. Determine the height of the tower. अपवर्ड मोशन डाउनवर्ड मोशन का जो स्टैंडर्ड रिजल्ट्स है उसको तुम यूज करो क्वेश्चंस में ज्यादा. डोंट ऑलवेज गो फॉर अप्लाइंग द इक्वेशंस एंड ऑल, क्योंकि थोड़ा सा टाइम तो वो कंज्यूम करेगा. जैसे एच हाइट गिरने में कितना टाइम लगता है? अंडर रूट टू एच बाई जी. एक्स हाइट गिरने में कितना टाइम लगेगा? अंडर रूट टू एक्स बाई जी. एच माइनस वाई हाइट गिरने में कितना टाइम लगेगा? अंडर रूट टू टाइम्स एच माइनस वाई बाई जी. थिंक, ट्राई टू गेट द रिजल्ट. टाइम टेकन बाय द फर्स्ट बॉल टू रीच द बॉटम इज दिस, है ना? अगर एच हाइट मान लेते हैं तो T1. टाइम टेकन बाय द सेकेंड बॉल टू रीच द बॉटम इज दिस, दिस इज T2. ओके, अच्छा, फर्स्ट बॉल कितना गिरा जब सेकेंड बॉल रिलीज किया गया? What was the distance traveled by the first ball when second ball was released? X height गिरा था नीचे, तो can I say difference of these two is nothing but under root 2x by g? तो अगर दोनों का डिफरेंस लेते हैं तो इट विल बी 2h by g minus under root 2 times h minus y by g, that is equal to under root 2x by g. तुम बहुत सारे t को कैरी कर रहे हो ना, बिकॉज ऑफ दैट वो थोड़ा सा फंस जा रहा है इक्वेशन. उसको तुम h के टर्म्स में एक्सप्रेस करो, मतलब डोंट ऑलवेज रिलाई ऑन द इक्वेशंस, यूज रिजल्ट्स ऑल्सो. ठीक है, सॉल्व करते वक्त. तो अब यहाँ से तो सॉल्व हो जाएगा ये, h ही तो निकालना है. g is getting cancelled out. if we cancel this 2 out तो बचता है अपने पास ये इक्वेशन, अंडर रूट h minus under root h minus y is equal to under root x. So solve for this and see what you are getting. I think better will be to bring this x to the other side and h minus y को एक तरफ. तो ये क्या आ जाएगा, रूट h minus root x will be under root h minus y. Now if we square both sides, we'll be getting h plus x minus 2 root hx is equal to h minus y. And this h is getting cancelled out. बचता है अपने पास यहाँ पे 2 root hx is equal to x plus y. If we square both sides once again, hx का वैल्यू आ जाता है x plus y whole square divided by 4, which means h is equal to x plus y whole square upon 4x. ठीक है. अंशु, कर लिया इसको? Should we go to the next one? Amber, salt. This is the answer that you are getting. ठीक है. Air resistance. Write down. Motion under gravity in presence of air resistance. Motion under gravity in 1D in presence of air resistance. If the ball is thrown upward, so direction of motion will be upward, means the air resistance has to be acting in the downward direction, है ना? And usually constant air resistance लिया जाता है, कभी कभी ऐसा भी बोला जाता है कि it is proportional to the speed of the particle. ठीक है, क्योंकि विस्कस ड्रैग जो लगेगा उसके ऊपर वो वेलोसिटी के प्रोपोर्शनल होगा, जितना ज्यादा फास्ट मूव करोगे उतना ज्यादा ड्रैग लगेगा. ठीक है, तो वी आर गोइंग टू सी फर्स्ट द केस वेयर इन, मतलब आई थिंक वी हैव ऑलरेडी डन वेलोसिटी प्रोपोर्शनल वाला ड्रैग, है ना? जो हमने कांस्टेंट एक्सेलरेशन में एक सवाल देखा था, वहां पे हम लोगों ने किया था व्हेन द वेलोसिटी इज प्रोपोर्शनल. नेट एक्सेलरेशन तुमको लिखना होता है, डिफरेंशियल इक्वेशन फॉर्म करना होता है, सॉल्व करना होता है इसको. ठीक है, यहाँ पे हम लोग कांस्टेंट एक्सेलरेशन अगर अज्यूम करते हैं, द एयर ड्रैग इज गिविंग अ कांस्टेंट एक्सेलरेशन टू द बॉल. सो कैन यू टेल मी कि अगर जैसे ये बॉल को प्रोजेक्ट किया हमने यू स्पीड से, तो व्हाट इज द टाइम टेकन बाय इट टू रीच द टॉप मोस्ट पॉइंट? मान लेते हैं कि ये ए नॉट, sorry, a naught is the acceleration imparted by the air drag in this case, which is constant. Acceleration imparted by air drag. तो कितना आ जाएगा यहाँ पे? टाइम ऑफ असेंट इन दिस केस विल बी हाउ मच? द ओनली थिंग इज दैट कि यहाँ पे जी इफेक्टिव लेना पड़ेगा हमको, है ना, बिकॉज वाइल इट इज मूविंग अप, जी तो इसके पास था ही, एंड along with that we have a naught in the downward direction because of the air drag. So can I say time of ascent in this case will be u divided by g plus a? ये आ जाएगा using the first equation of course, time taken to reach zero velocity. ठीक है, तो final velocity is zero, initial velocity u, net acceleration is g plus a naught, and time you are supposed to calculate. First equation से आ जाएगा ये result. ठीक है, so can you tell me what is the time of descent now? कितना टाइम इसको लगेगा नीचे आने में? नो, u by g minus a naught is not correct, बिकॉज वाइल इट इज मूविंग अप, नो, वो क्या कर रहा है कि अब तुम सोचो कि ये लैंड अगर करता यू स्पीड से तब वो करेक्ट होता है कि नहीं, लेकिन ये यू स्पीड से थोड़ी नहीं लैंड करेगा, ड्रैग की वजह से एनर्जी लूज करेगा, काइनेटिक एनर्जी लूज होगा इसका. हाँ, इट विल बी एक्टिंग इन द ऑपोजिट डायरेक्शन फॉर श्योर, लेकिन यू नीड टू अंडरस्टैंड वन थिंग. जैसे यहाँ पे ये डाउनवर्ड डायरेक्शन में जी तो है ही, इसको जो ए नॉट मिल रहा है अपवर्ड डायरेक्शन में मिल रहा है, सो नेट एक्सेलरेशन इज जी माइनस यू ए नॉट, बट द वेलोसिटी विद विच इट इज हिटिंग द सरफेस इज नॉट इक्वल टू यू, इसलिए यू डिवाइड बाई जी माइनस ए नॉट विल नॉट बी द वैल्यू. तो क्या वैल्यू होगा फिर टाइम ऑफ डिसेंट के लिए? ऑफ कोर्स दे आर नॉट इक्वल, और डिसेंट में शायद आई थिंक टाइम तुमको ज्यादा लगना चाहिए. क्यों? एनर्जी लूज कर रहा है ना ये तो, द स्पीड विथ विच इट इज गोइंग टू हिट द सरफेस, क्योंकि एक्सेलरेशन एनीवे क्या था, ज्यादा था ही, and the speed with which it is hitting the surface is also less. क्या कॉमन है इसमें? हाइट इज कॉमन, isn't it? जितना हाइट ऊपर गया उतना हाइट नीचे आएगा, so height is something that is common, so try to make use of that and find out the answer. Time of descent. Can I say time of descent in this case will be under root 2h divided by g minus a naught? करेक्ट है? नेट एक्सेलरेशन जी माइनस ए नॉट, और कितना हाइट गिर रहा है ये मान लेते हैं एच हाइट गिर रहा है, एंड दैट एच हाइट वी कैन रिलेट विद दिस यू एंड जी प्लस ए नॉट, नो. तो यहाँ पे अगर सब्स्टिट्यूट करते हैं वैल्यू को तो कितना आ जाता है ये? अंडर रूट यू स्क्वायर डिवाइड बाई जी प्लस ए नॉट into g minus a naught, isn't it? So this term will get reduced to u divided by under root g plus a naught into g minus a naught. Is this what we are getting? Height को हमने क्या सब्स्टिट्यूट कर दिया? u square by 2 times g plus a naught. 2 cancel out होके बच गया अपने पास ये. And it's clearly visible that time of descent in this case will be greater as compared to time of ascent, है ना? करेक्ट है ना? सो दैट लिंक इज बेसिकली द हाइट, अपवर्ड डाउनवर्ड मोशन में हाइट कॉमन है, उसको पकड़ के फिर हमने निकाल लिया इसको, असेंट एंड डिसेंट को. गेट इन द प्रैक्टिस ऑफ यूजिंग द रिजल्ट्स, थोड़ा सा फास्ट करेगा तुमको, है ना. डोंट जस्ट रिलाई ऑन इक्वेशंस ऑफ मोशन ऑल द टाइम. जितना ज़्यादा क्वेश्चंस करोगे अपने आप ही हैबिट में आ जाएगा वो. बॉल थ्रोन डाउनवर्ड्स, अगेन दिस यू कैन अंडरस्टैंड, जो तो कॉन्सेप्ट था वैसा ही है ये भी. देखो ये वाला क्वेश्चन, एन एलिवेटर कार हुज फ्लोर टू सीलिंग डिस्टेंस इज equal to 2.7 meter, starts ascending with a constant acceleration of 1.2 meter per second square. Accelerate कर रहा है ये lift. 2 seconds after the start, a bolt begins to fall from the ceiling of the car. Find the bolt's pre-fall time. आ जाएगा ये. Again, bolt will have some velocity as seen from the ground frame. And at the same time, lift is also traveling in upward direction. Relative से करोगे तो I think easy हो जाएगा. Make use of relative and find out the answer. Displacement and the distance covered by the bolt during the free fall in reference frame fixed to the elevator shaft. Find the answer for this. Karo. Now, when they say elevator shaft, what exactly they are referring to? Is it with respect to the elevator? Ground के respect में है ना? Because shaft is actually stationary. तो elevator के respect में नहीं, ground के respect में पूछ रहा है. You want to write an advanced paper today? Motion in 1D पे. Only physics. After 1:30 लंच करके आ जाओगे तो फिर पेपर मिल जाएगा. क्या टेक होम असाइनमेंट लेना है? बट टेक होम असाइनमेंट चाहिए, बैठ के यहाँ पे लिखना. Till 3 o'clock you are here, no? 2:30 you are going back. Okay. Cabin is already built, I think. Have you seen that? देखा नहीं है जाके? I think cabin बन गया. Students were writing the test yesterday. जो इस बार जेई दे रहे हैं उसी कैबिन में बैठ के. तो आई थिंक मतलब बैठने लायक होगा तभी तो बैठ रहे हैं वो. तो आई गेस एसी वगैरह तो लग गया है शायद अंदर. देखना एक बार. Just that your classes are not happening in cabin right now because that board and all those setup is not done. ऐसे क्लासेस वहीं वहाँ पे होगा तुम्हारा. एक बोर्ड लगा दिया जाएगा वहाँ पे छोटा सा. Throughout the day you can sit there. आ गया? Okay. First one तो easy है. Bolt free fall time. So with respect to the elevator, if we see, कितना आ जाएगा यहाँ पे? With respect to the elevator. So can I say that the velocity is 0? क्योंकि ये just drop हो रहा है elevator के अंदर. ठीक है? What distance it is covering in the elevator? 2.7 meter. And the acceleration with respect to elevator is how much? G minus, मतलब acceleration of bolt with respect to elevator is going to be acceleration of bolt minus acceleration of elevator. Okay. The acceleration of bolt is G, which is 10 लिया है क्या? 10 ले लेते हैं, ठीक है. So let's take it as 10 minus of minus 1.2 you can take. ठीक है, तो what value you are getting, because elevator is accelerating upward है ना, and bolt का जो acceleration है downward है, so that's why the net acceleration with respect to the elevator is coming out as 11.2 meter per second square. ठीक है, अब यहाँ से आ जाएगा, कितना आ जाएगा टाइम ऑफ फ्लाइट, अंडर रूट 2 टाइम्स 2.7 डिवाइड बाई 11.2, क्या वैल्यू आ जाता है यहाँ से, 54/112 inside the root. 27/56. Further cancellation is not possible, no? तो रूट 27/56 जैसा कुछ आएगा टाइम. Now what they are asking you is displacement and the distance covered by the bolt during the free fall in the reference frame fixed to the elevator shaft. मतलब ground frame में निकाल दो इसका displacement और distance traveled. तो ग्राउंड फ्रेम में डिस्प्लेसमेंट इक्वेशन तो सेकंड इक्वेशन से डायरेक्टली आ जाएगा. व्हाट इज द नेट डिस्प्लेसमेंट बताओ, क्या लिखेंगे हम लोग यहाँ पे, नेट डिस्प्लेसमेंट इज यूटी प्लस हाफ जी टी स्क्वायर माइनस हाफ जी टी प्लस हाफ जी टी स्क्वायर, वी विल राइट हाफ ए टी स्क्वायर. So displacement is going to be, initial speed is how much in the ground frame, 2 seconds के बाद तो 2.4, so I can say 2.4 is the value. और टाइम कितना लग रहा है उसको, ये वाला टाइम, ठीक है, कितना आता है ये, क्लोज टू रूट 27/56 विल बी क्लोज टू हाउ मच, 54 होता तो 1/2 आ जाता, 0.7, अच्छा 707 आता है ना 1/√2 का वैल्यू, तो 0.7 अज्यूम कर लेते हैं. वी कैन टेक इट एज 0.7 माइनस हाफ इंटू 10 मल्टीप्लाइड बाई टी स्क्वायर, 10 ही लिया था ना हमने, हाँ, टी स्क्वायर इज गोइंग टू बी 0.7 का होल स्क्वायर विल बी 0.5 के क्लोज क्लोज ले लेते हैं. ठीक है, व्हाट वैल्यू वी आर गेटिंग, ये आ जाएगा तुम्हारा 24 इंटू 7 इज हाउ मच, 1.6 आ रहा है ये, 1.6 close to 1.7, okay, so 1.7 minus 2.5 के बराबर, so what value we are getting from here finally, 0.8 meter, so close to 0.8 meter in downward direction we are getting. This is the displacement of the bolt. ठीक है, distance covered अब पूछ रहा है तुमसे ये, तो कर दोगे इसको, not hard. हाँ, so it is like from its initial position it has fallen by a distance of this much, बोल सकते हैं ऐसा, and while moving up and down what is the total distance it is covering, maximum height तक जाके वापस लौटेगा ना, तो u square by g, isn't it? देखो जैसे बोल्ट यहाँ पे था, ठीक है, यहाँ पे बोल्ट है, डिस्प्लेसमेंट क्या आया इस पोजीशन से 0.8 मीटर नीचे, ठीक है, इसका मेरे को स्पीड पता है, मेरे को डिस्टेंस कवर्ड बाय द बोल्ट चाहिए, ठीक है, तो इसका मेरे को स्पीड पता है, तो दैट मीन्स ये अपना इनिशियल स्पीड से राइज करा होगा थोड़ा सा और उसके बाद फिर वापस लौटा होगा, वट एवर हाइट इज इज कवरिंग इन अपवर्ड डायरेक्शन सेम हाइट इट इज कवरिंग इन डाउनवर्ड डायरेक्शन, देन फर्दर फॉलिंग बाय 0.8, कैन वी से दैट. तो ये कितना हाइट ऊपर जाता है ग्राउंड से, तो हमको यही लगेगा ना यू स्क्वायर बाय 2g के बराबर, ठीक है, एंड देन यू स्क्वायर बाय 2g डाउन. हाँ दैट्स व्हाट, तो कितना आ जाएगा यू स्क्वायर बाय जी प्लस 0.8, क्या आ जाता है, क्या आ जाता है देखो डिस्टेंस टोटल, u का वैल्यू कितना है इसका 2.4, राइट, सो 2.4 यू स्क्वायर बाई 2g प्लस u square is going to be 2.4 का whole square. So 5.76 by, is it 5.76 आ रहा है ना ये वाला, 0.576 राइट, वही आएगा ना 5.76 डिवाइड बाय 10, तो 0.576 एंड दिस इज गोइंग टू बी 8, 1.376 के क्लोज क्लोज आंसर आ रहा है. ठीक है, दिस इज द डिस्टेंस कवर्ड इन दिस केस. अच्छा एक और चीज, यू स्क्वायर बाई टू जी का वैल्यू, यू स्क्वायर बाई टू जी का वैल्यू कितना आया? दैट वाज कमिंग आउट एज 0.29 के आसपास, 0.29 के आसपास है ना. हाँ, व्हाट वाज द डिस्टेंस कवर्ड बाय लिफ्ट ड्यूरिंग द सेम टाइम? What was the distance covered by lift during the same time? It was moving up, no? With an acceleration of. हाँ, तो teasing में क्या होगा? क्या लिफ्ट से दोबारा से टकराएगा ये? Because lift has an acceleration in upward direction, rather bolt has a deceleration in downward direction. तो ऐसा नहीं होगा कि ये लिफ्ट से वापस से टकरा गया. So it will be rising inside the lift only, and then after that it will come down. जैसे हमको दिखाई देगा, है ना? This one. Two particles 1 and 2 moves with constant velocities of v1 and v2 along two mutually perpendicular directions towards the point of intersection O. At t is equal to 0, the velocities particles were located at L1 and L2 from O. How soon will the distance between the particle become smallest? How will you do it? कैलकुलस यूज करके कर सकते हो, ठीक है, वो तो कर ही सकते हैं हम लोग. कैन यू नॉट यूज रिलेटिव ऑल्सो टू गेट द सिमिलर काइंड ऑफ रिजल्ट? ये L1 है, ये L2 है, ठीक है. दिस वेलोसिटी इज v1 एंड दिस वेलोसिटी इज v2. ठीक है, एक तरीका तो ये हो गया क्योंकि वी कैन से L1 minus V1t is the distance of this particle from origin at time t, and इसका उतना ही टाइम में क्या आ जाएगा, L2 minus V2 into t. So the separation between them is going to be, मतलब वही राइट एंगल ट्राइंगल यहाँ पे बनेगा. हाइपोटेनियस का लेंथ निकालो और उसको डिफरेंशिएट करके जीरो से इक्वेट करो, गेट द वैल्यू ऑफ टाइम, एंड देन आफ्टर दैट सब्स्टिट्यूट टू गेट द वैल्यू ऑफ टोटल स्मॉलेस्ट सेपरेशन. ठीक है, दूसरा तरीका ये भी हो सकता है कि इफ आई टेक द वेलोसिटी ऑफ दिस 2 विथ रिस्पेक्ट टू 1 या वेलोसिटी ऑफ 1 विथ रिस्पेक्ट टू 2, इसको अगर तुम ऑब्जर्वर अज्यूम कर लो, इफ यू कंसीडर दिस एज ऑब्जर्वर, तो इस ऑब्जर्वर को क्या फील हो रहा है क्योंकि इट हैज गॉट वन ऑफ इट्स ओन वेलोसिटी v1, बट इट ऑल्सो हैज अ नेगेटिव वेलोसिटी ऑफ दिस, इजंट इट? तो इसका वेलोसिटी इधर था, इसका मतलब इसको तुम इधर वेलोसिटी दे दो, है ना. तो एज सीन बाय दिस ऑब्जर्वर, this particle is actually moving along this direction somehow, है ना. तो shortest distance is going to be what? The perpendicular distance. ठीक है, इसको हम कैलकुलेट कर लेंगे. So tell me the answer using this. ये एंगल कितना आ जाएगा? What is this angle? Tan theta is v1 upon v2. Okay, तो ये वाला एंगल मेरे पास है ऑलरेडी. We have a right angle triangle in which this angle is known to us. So can we find out the distance now? परपेंडिकुलर डिस्टेंस पूछ रहा है या क्या पूछ रहा है? हाउ सून द डिस्टेंस बिटवीन द पार्टिकल्स विल बिकम स्मॉलेस्ट, कितने टाइम के बाद स्मॉलर डिस्टेंस पे आ जाएगा ये. तो जितने टाइम में ये वाला पार्टिकल यहां पहुंच जाएगा, तो व्हाट इज द टाइम टेकन बाय दिस पार्टिकल टू रीच दैट पॉइंट? if this triangle is known to us, can we say कि ये अगर L हो गया, L1 हो गया, this is going to be L1 by x is equal to कितना आ जाएगा, tan theta. तो x is going to be how much? L1 cot theta, right? So this length is L1 cot theta. तो ये क्या आ जाएगा इससे? L2 minus L1 cot theta. तो वी कैन एक्चुअली फाइंड आउट दिस लेंथ नो, और फिर बोल देंगे कि स्पीड तो इसका पता है हमें, रिलेटिव स्पीड क्या है और रिलेटिव डिस्टेंस क्या कवर किया है, दोनों को डिवाइड कर देंगे तो टाइम आ जाएगा। राइट, so this is the approach of using the relative motion in this case। ठीक है, लिखो ग्राफ्स, ग्राफिकल रिप्रेजेंटेशन ऑफ मोशन, ग्राफिकल रिप्रेजेंटेशन ऑफ मोशन। तो ग्राफ इज अ वेरी गुड वे ऑफ रिप्रेजेंटिंग द डेटा, जिसमें कि हम बहुत सारा इंफॉर्मेशन एक लिमिटेड स्पेस में कैप्चर कर सकते हैं। लेट्स से द पोजीशन ऑफ अ पार्टिकल इज चेंजिंग विद टाइम and I want to map the position of the particle with time at each and every instant of time। ठीक है, तो by a continuous graph we'll have to show that, है ना। तो जैसे xt ग्राफ हो गया ऐसे, हालांकि हमने जान तो लिया ही है कि क्या कौन से ग्राफ से क्या मिलेगा हमें, है ना। तो सपोज इफ xt ग्राफ इज गिवन टू अस लाइक दिस, वी नो दैट स्लोप ऑफ दिस टेंजेंट टू xt ग्राफ इज गोइंग टू टेल अस व्हाट। जैसे इस पॉइंट पे अगर मैं एक टेंजेंट ड्रॉ करता हूं, ये अगर थीटा हो गया, सो व्हाट इज tan थीटा इन दिस केस, it will give us the velocity at point p। okay, t is equal to t naught पे है ये, तो at t is equal to t naught we can write। okay, so slope of this graph will give us the value of velocity at time t is equal to t naught। what about the double derivative of this? Double derivative is going to give us the acceleration। so इसका जो कॉन्केविटी होता है उसको देख के हम लोग बता सकते हैं कि एक्सेलरेशन क्या होगा, पॉजिटिव होगा, नेगेटिव होगा, क्या होगा। यहाँ पे जैसे वेलोसिटी क्या है, व्हाट इज वेलोसिटी, लेस देन 0। इफ इट इज, मतलब यूजुअली जब भी हम ग्राफ को ऑब्जर्व करते हैं तो वी कंसिडर आवरसेल्फ टू बी अबव द ग्राफ। ओके, और उसको देख के फिर हम बताते हैं कि ये कॉन्केव है, कॉन्वेक्स है, क्या है। सो लेट्स से इफ इट इज ओपनिंग अप, ऊपर के डायरेक्शन में अगर ओपन कर रहा है तो इसका मतलब ये कॉन्केव अप हो गया, तो कॉन्केविटी इज गोइंग टू बी पॉजिटिव इन दिस केस। इफ कॉन्केविटी इज पॉजिटिव विच मीन्स द एक्सेलरेशन विल बी positive। okay, because d2x by dt2, that means the double derivative of the position actually tells you about something about the radius of curvature thing। okay, तो मतलब जैसे रेडियस और कर्वेचर का ऐसा कुछ फॉर्मूला होता है, आगे चल के हम सर्कुलर मोशन में इसको देखेंगे। वैसे dx अपॉन dt पावर 3/2, मतलब xt ग्राफ का बात कर रहा हूँ उसमें, सॉरी, का होल स्क्वायर पावर 3/2 होल डिवाइड बाई डी स्क्वायर एक्स बाई डी टी स्क्वायर। ठीक है, तो अगर इस ग्राफ का कर्वेचर मेरे को फाइंड आउट करना हो तो यूजिंग दिस विल बी डूइंग इट, विच वी विल डिराइव इवेंचुअली इन सर्कुलर मोशन। ठीक है, इसको सर्कुलर मोशन में हम लोग देखेंगे। तो तुमको ये चीज समझ में आना चाहिए कि जो रेडियस ऑफ कर्वेचर होता है दैट हैज समथिंग टू डू विथ दिस थिंग। ओके, इससे इसका कुछ लेना देना होता है सेकंड डेरिवेटिव से। ठीक है, तो ये कॉन्केविटी के बारे में बेसिकली बताता है तुमको। तो कॉन्केविटी इज इन अपवर्ड डायरेक्शन, मतलब रेडियस ऑफ कर्वेचर इधर ही होगा ना कहीं पे इसका। तो कॉन्केविटी मतलब पॉजिटिव अगर हो गया तो इसका मतलब तुम्हारे तरफ वो ओपन अप हो रहा है ग्राफ। ठीक है, तो acceleration in this case, directly looking at the graph, you can say it is going to be positive। other way around what you could have done in this case is कि तुम velocity को एनालाइज करो टू डिफरेंट टाइम्स पे और उससे बता दो। जैसे velocity की अगर हम बात करें तो यहाँ पे θ1 है मान लो, और कुछ टाइम के बाद अगर देखते हैं द टेंजेंट विल बी लाइक दिस। ठीक ठीक है, तो वी कैन से दैट द वेलोसिटी इज आई मीन द पोजीशन इज इवन चेंजिंग स्लोअर इन दिस केस, इजंट इट। इसका जो स्टीपनेस है उस पर क्या असर पड़ा है इसमें, ये जो थीटा है θ2, tan ऑफ θ2 विल बी डेफिनेटली लेसर नो, ऑब्ट्यूज एंगल हो गया ये। ठीक है, मैग्नीट्यूड की बात कर रहे हैं तो स्पीड डाउन हो रहा है या स्पीड अप हो रहा है, यहाँ पे इट इज स्पीडिंग डाउन। तो स्पीडिंग डाउन मतलब अगर वेलोसिटी नेगेटिव है तो एक्सेलरेशन को पॉजिटिव होना चाहिए, तभी तो ऐसा हो सकता है ना। दे हैव टू बी इन ऑपोजिट डायरेक्शन इन ऑर्डर फॉर द बॉडी टू डिसेलरेट और रिटार्ड। ठीक है, तो आइदर यू गो बाय लुकिंग एट द कॉन्केविटी ऑफ द ग्राफ, या फिर तुम क्या कर सकते हो कि वेलोसिटी एक्सेलरेशन देख लो कि वेलोसिटी डिक्रीज कर रहा है, इंक्रीज कर रहा है इन द एक्सटी ग्राफ, एंड देन कम टू अ कंक्लूजन फ्रॉम देयर। ओके, क्लियर है ये चीज? ओके, तो अगर मान लो कि डिफरेंट टाइप्स ऑफ बॉडीज की अगर बात करें तो जैसे पहला केस हम लोग देखते हैं बॉडी एट रेस्ट। किस तरह का है एक्सटी ग्राफ बनेगा यहाँ पे? If the body is at rest, the position should not change with respect to time, isn't it? So this kind of a graph, or even at the origin also you can construct that graph. Okay. Then second one is in uniform motion. Uniform motion में क्या होता है? Velocity is constant, and if velocity is constant, we know that the slope of this has to be constant. तो स्लोप कांस्टेंट होने का मतलब कि कुछ स्ट्रेट लाइन ग्राफ बनेगा ये यहाँ पे, ऐसे बन सकता है या फिर ऐसे बन सकता है, ठीक है, या ऐसे बन सकता है. व्हाट डज ऑल दीज ग्राफ्स रिप्रेजेंटिंग इन दिस केस? इसको देख के तुम क्या बोलोगे कि इनिशियल पोजीशन ऑफ द पार्टिकल वाज पॉजिटिव इन पॉजिटिव एक्स डायरेक्शन साइड, नॉट स्टार्टिंग फ्रॉम ओरिजिन, एंड देन स्लोप इज पॉजिटिव, मतलब ये किस डायरेक्शन में जा रहा है यहाँ पे? थीटा इज ऑल्सो एक्यूट, नो? तो इसके लिए एक्स इनिशियल was greater than 0, and then velocity is also greater than 0. That means the body is moving in positive direction. Okay, what about this case? X initial is equal to 0, velocity is also greater than 0. यहाँ पे क्या आ जाएगा वैसे ही? X initial is less than 0. What about velocity in this case? Velocity is less than 0, no? क्योंकि slope इसका negative है again. Now what about the case, like बताओ कैसा ग्राफ होना चाहिए जिसमें तुम्हारा x लेस देन 0 हो और v ग्रेटर देन 0 हो? मतलब इट शुड बी समथिंग लाइक दिस, राइट? मतलब x initial is going to be, this is x initial, right? In this case x initial is less than 0 but velocity is greater than 0. That's the reason why इसका जो पोजीशन है, x का जो वैल्यू है, नेगेटिव में डिक्रीज करता जा रहा है, एंड इवेंचुअली इट विल बी क्रॉसिंग द ओरिजिन एट दिस पॉइंट, एंड फिर उसके बाद क्या होगा कि ये पॉजिटिव डायरेक्शन में मूव करता जाएगा, ठीक है? Now, these all are the cases of uniform motion. Third, uniform acceleration or retardation. जैसे ये ग्राफ हो गया. What is the initial position of the graph in this case? कुछ इसके पास x नॉट इनिशियल कोऑर्डिनेट था, x नॉट से ये स्टार्ट करता है. नाउ व्हाट इज हैपनिंग टू द स्लोप? जैसे अगर दो इंस्टेंट ऑफ टाइम अगर हम लोग यहाँ पे ले लें t1 एंड t2, तो आई कैन क्लियरली सी दैट द स्लोप इज इंक्रीजिंग हियर, राइट? और ऐसे भी ग्राफ इज टर्निंग टुवर्ड्स y एक्सिस, इसका मतलब स्टीपनेस बढ़ता जा रहा है इसका, मतलब द वेलोसिटी इज गोइंग ऑन इंक्रीजिंग. कैन आई से वेलोसिटी एट t1 is lesser than velocity at t2, which means acceleration, the body is speeding up. So velocity clearly is greater than 0 in this case, and acceleration is also greater than 0 in this case, ठीक है? And initial position was also greater than 0. What about this case, this graph, xt graph? इसको देख करके बताओ ये सारे मोशन पैरामीटर्स के बारे में. इनिशियल पोजिशन इज ऑफ कोर्स ऑरिजिन, वो तो दिख रहा है हमको. Now it is bending towards x axis, which means the slope is going on decreasing. तो क्या बोल देंगे हम लोग यहाँ पे? वेलोसिटी इज ग्रेटर देन 0, लेस देन 0. व्हाट इज दैट? स्लोप इसका पॉजिटिव ही है ना. वी कैन से वेलोसिटी इज ग्रेटर देन 0, एक्सेलरेशन इज लेस देन 0, राइट? चले नेक्स्ट. अच्छा, समटाइम्स दे आस्क यू अबाउट मूविंग अवे फ्रॉम द ओरिजिन टुवर्ड्स द ओरिजिन लाइक दैट. ओके, तो वही अब तुम देखो कि डायरेक्शन क्या है उसका मोशन का, बेस्ड ऑन दैट यू कैन एक्चुअली डिसाइड दैट. फाइन. थर्ड, नहीं, तीसरा वाला केस ही तो देख रहे हैं ना हम लोग. नेक्स्ट देखते हैं एक्सटी ग्राफ. मान लो ऐसा है. व्हाट कैन यू से अबाउट दिस एंड दिस? इसको 1 और इसको 2 बोल देते हैं. डायरेक्शन ऑफ मोशन बताना है, एक्सेलरेशन बताना है, रिटार्डिंग और एक्सेलरेटिंग ये बताना है. v इज लेस देन जीरो क्लियरली, क्योंकि ये तुम्हारा स्लोप इसका. a is less than zero because again bending towards y axis means this, the value of velocity goes on increasing. What about this? v is greater than zero क्योंकि slope इसका positive आ रहा है, and a is greater lesser, speeding up हो रहा है again, तो a is also greater than zero in this. Okay, fine. ये तो हमने देख ही लिया है. खैर क्या आ जाएगा इसमें? velocity is less than zero and a is greater than zero, right? That's the reason why again turning towards x axis side. Okay, तो ये कुछ केसेस हो गया एक्सेलरेशन एक्सेलरेटेड मोशन का. राइट डाउन वीटी ग्राफ, डिफरेंट टाइप्स ऑफ मोशन वी विल सी, और उसके बाद कंबाइन करके प्रॉब्लम्स देखेंगे इसका. राइट डाउन वीटी ग्राफ. तो अगेन फर्स्ट केस आई एम टेकिंग एज बॉडी एट रेस्ट, which is pretty much straightforward. You can say that the graph will be looking like this. ये जैसे v हो गया, ये जैसे t हो गया. सो कैसा ग्राफ आ जाएगा इसमें? ग्राफ विल बी समहाउ लाइक दिस, राइट? वेलोसिटी को जीरो होना पड़ेगा रेस्ट के लिए, तो अलोंग द टाइम एक्सिस इट विल बी. ठीक है, तो ये हो गया बॉडी एट रेस्ट. सेकंड है यूनिफॉर्म मोशन. यूनिफॉर्म मोशन मीन्स द वेलोसिटी हैज टू बी कांस्टेंट. ठीक है, v t, v is greater than जीरो एंड इसके लिए v is less than जीरो. ठीक है, यूनिफॉर्म एक्सेलरेशन. एक्चुअली दिस vt ग्राफ इज द मोस्ट यूजफुल ग्राफ, है ना? क्योंकि तुम डिफरेंशिएट करते हो तो भी तुमको कुछ मिलता है, इंटीग्रेट करते हो तो भी तुमको कुछ मिलता है, राइट? सो दैट्स द रीजन व्हाई इवन द स्लोप एज वेल एज एरिया बोथ आर मीनिंगफुल हियर. इवन मीनिंगफुल तो वहां भी होता है एक्सेलरेशन टाइम ग्राफ में भी, लेकिन फिर वही है कि जर्क वगैरह हम लोग नहीं देखते हैं यहाँ पे मोशन पैरामीटर्स में. यूनिफॉर्म एक्सेलरेशन, द ग्राफ विल बी समहाउ लाइक दिस. फिर वही दो तीन ग्राफ मैं यहाँ पे बना रहा हूँ. इसको 1 बोल देते हैं, इसको 2 बोल देते हैं, इसको 3 बोल देते हैं, और इसको 4 बोल देते हैं. टेल मी अबाउट 1 2 3 4. फर्स्ट केस में व्हाट अबाउट इनिशियल वेलोसिटी? फर्स्ट ग्रेटर देन जीरो, मतलब रेस्ट से स्टार्ट नहीं कर रहा है. इसके बाद velocity was always positive. Okay, velocity was always positive. What about acceleration? Acceleration is greater than zero, that means accelerated motion. This is second one is velocity is initial velocity is negative. तो initially क्या कर रहा है? Let's take t naught here. So 0 to t naught what is happening, and t naught के beyond what is happening? 0 to t naught the body is retarding, isn't it? क्योंकि स्पीड का वैल्यू डिक्रीज कर रहा है, स्पीडिंग डाउन हो रहा है. ठीक है, तो 0 to t naught के लिए we can say that velocity was negative but acceleration is positive. That's the reason why retardation was happening. And t naught से t greater than t naught के लिए velocity is also positive, acceleration is तो anyway positive because straight line है, slope constant रहेगा उसका, ठीक है. तो ये accelerated motion कर रहा है t नॉट के बाद, t नॉट तक retarded motion है. What about 3? Started from a positive velocity but the velocity went on decreasing. तो acceleration is less than 0, velocity is again वही split कर सकते हैं इसको time में t नॉट. So 0 to t naught, v greater than 0, a less than 0, and t naught के beyond v less than 0, a is also less than 0, accelerated motion. and 4 में भी वैसे ही लिख लोगे, right? 4 के लिए the initial velocity is 0 and it went on increasing in the negative direction, so slope is going to be negative, acceleration is negative. ठीक है, चले आगे. देखो इस क्वेश्चन को देखो. A point travels along x-axis with velocity whose projection is whose vx is presented as a function of time by the plot given. Assuming the coordinate of particle x is equal to 0 at moment t is equal to 0, draw an approximate time dependency of acceleration versus x. Acceleration wx, the x coordinate and distance covered. ठीक है, मतलब वही xt graph, then distance time graph and acceleration time graph, all three you have to plot. प्लॉट करके बता दो इसका. Slope gives you what here? Slope is acceleration, area is displacement, right? Slope gives you acceleration, area is displacement. जीरो टू 1 सेकेंड में एक्सेलरेशन क्या है इसका? स्लोप इज 1, राइट? कितना आ जाएगा स्लोप उसका स्ट्रेट लाइन का? y इज इक्वल टू एक्स जैसा ग्राफ है वो, विच मीन्स स्लोप इज 1, so acceleration is 1 meter per second square. And then 2 to 4, what is the value of acceleration? 0. And then 4 to 6, I think 6 नहीं 7 क्या है? I think 0 to 1 acceleration is positive, 2 to 3 1 to 3, sorry, 1 to 3 acceleration 0, 3 to 4 acceleration negative, again 3 to 4 nahi, 3 to in fact 6, 3 to 6 acceleration negative, and then 6 to 7 acceleration is positive. ठीक है, तो ड्रॉ कर दो इसको, प्लॉट इट, जल्दी जल्दी से प्लॉट करो और दिखाओ मेरे को. AT graph, XT graph, distance time graph. डन. ये कौन सा है? डिस्प्लेसमेंट। ओके, 3 तक है ऐसे ये। ठीक है, देख लो ना बॉक्सेस, थोड़ा पहले पहले कर दिया इसको। 1 तक, 0 से 1 तक एक्सेलरेशन। ना 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 ना, हाँ, समझ में आया तुमको? 0 से 1 तक एक्सेलरेशन दिख रहा है, 1 से 3 तक ये कांस्टेंट स्पीड से है। ठीक है, हाँ 3। ठीक है, तो 3 के बाद 3 से लेके 6 तक इट इज गोइंग टू बी, जब वेलोसिटी नेगेटिव हुआ तो 3 से लेके 4 तक वेलोसिटी वाज पॉजिटिव बट वाज डिक्रीजिंग। हम्म, बिकेम 0। उसके बाद तो नेगेटिव में जाएगा ना, velocity became negative, isn't it, after 4 second? तो still it went in the downward direction only ना? इसको उठा क्यों दिया? हाँ, velocity का प्लॉट है। देखो 4 सेकेंड तक क्या है, 3 से 4 तक डिस्प्लेसमेंट इज पॉजिटिव बट बियॉन्ड। ओके, तुम 6 तक कर दियो इसको। ओके 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 फाइन, 6 तक किए हो और उसके बाद तुमने राइज कराया इसको। ठीक है, ठीक है फिर, ठीक है 7 तक। मेरे को लगा कि तुमने 4 तक इसको किया है यहाँ से यहाँ तक में। ठीक है, सो इट विल गो ऑन डिक्रीजिंग टिल 6। ओके, जहाँ पे ये एंड हो रहा है। करेक्ट, करेक्ट है। 80 इज लाइक दिस। डिस्टेंस में क्या करना है यहाँ पे, जहाँ जहाँ पे डिक्रीज हो रहा है वहां से बस रिफ्लेक्शन लेना है इसका। ठीक है, तो यहाँ यहाँ से ये ऐसे आ जाएगा, उसके बाद क्या होगा फिर? हम्म, ठीक है। अंशु आ गया? ये क्या है? स्ट्रेट लाइन जैसा दिख रहा है मेरे को, कर्व होना चाहिए ना यहाँ पे, एक्सेलरेशन है। थोड़ा सा करेक्ट करो उसको, और रिफ्लेक्शंस लेना है जहाँ जहाँ पे डिक्रीज हो रहा है वैल्यू ऑफ डिस्प्लेसमेंट। ठीक है, तो कन्वर्जेंस हैज टू बी वेरी क्विक क्वेश्चन सॉल्व करने के लिए। velocity displacement graph, before going into velocity displacement, AT graph. Okay, what's the time right now? 10:07 हो गया है। ठीक है, इसको कंटिन्यू करेंगे नेक्स्ट क्लास में, विल फिनिश दिस ऑफ और मिक्स क्वेश्चंस करेंगे बस। तो एडवांस वाला सेक्शन हो गया ना इसमें मॉड्यूल में? यू डिडंट कम
सॉल्व किया नवीन अवस्थी? कितना, कहाँ तक पहुंचे? 90? वेयर, हाउ फार? Module VP sheet you guys finished? No doubts in module VP sheet? But what about MS? MS कह रहा हूँ, sorry. Narendra Avasthi, how much did you do? अच्छा, नहीं किया अभी? DPP, अच्छा DPP 1 2 3 किया क्या इसका मोल का? तो 1 2 3 किया? तो 5 यू? ठीक है चलो, कूल. Which question? Which of the following contains greater number of molecules? Okay. So A is 1 mole molecule. B is half mole molecule. C is 1 mole molecule. D is 1 by 4 mole molecule. Oh, A and C. कोई नहीं, हो जाता है. A and C. Both are the answer. Anything else? A 0.014 gram sample of an organic compound is combusted in oxide of oxygen, gives CO2, which is the empirical formula of carbon. So this, I guess, first of all, this thing you know, CXHY plus X plus Y by 4O2 gives XCO2 plus, huh? Oh, so oh, these are hydrocarbon derivative, they should have said. It's okay. अच्छा, even then, okay, even then, let's see. अच्छा, इसमें options में सब में O है, तो this formula cannot be applied now, है ना? This formula cannot be applied first of all. हाँ, you can't apply that. This formula you can't apply. You have to apply CXHY OZ plus whatever. Let's say alpha O2 gives you XCO2 plus Y by 2 H2. Now this is the formula you apply. है ना? Then you got. Okay. No. Okay, let's see. And from here another thing I can say is like 2 alpha plus Z will be equal to Y by 2. So now they're saying this is 0.104 gram sample, okay, and this is 0.286 gram, and this is 0.117 gram. Okay, so basically 1 mole will produce Y by 2 moles. So I can say 1 mole will produce 2 by Y moles. And we have how many moles of H2 with this? How many moles? So we can find basically this mole, this is 0.117 by 18. This is moles of this. So 1 will produce y by 2. So this will produce how many? So from this you can get y. We can't get y. रुको, this again. So here this is 0.117 gram. This is what 18. This is the one, and this is 0.286 by 44 gram. So this is this many moles. So if I had 1 mole of this, I will get X mole of this, and I'll get Y mole of this. Now I have, let's say, 0.014 by M. It should be 0.104 by M into X, and this will be 0.014 by M into Y. This should be the number of moles, and this you can equate to this, and this you can equate to this. So what will you get? You'll get a relationship between X and Y. Correct. And then anything else? अच्छा, empirical formula निकालना है. Oh, empirical formula निकालना है of the hydrocarbon. How will you do that? Acha, okay, I understand. I think you actually don't need to do any of this. What you need to do is, you have this is the number of moles of this 0.286 by, basically you do 12 by 44. That will give you what? Moles of carbon, right? Same you do here, you do this into 2, this will give you what? Moles of hydrogen. Yeah? Wait, I'll tell you. So this is the weight of carbon, weight of oxygen, hydrogen, and in the beginning you have 0.104. You subtract those two values from that value, you get the weight of oxygen. Now from there on you can just solve the question. No, that you don't need to worry about. I'm saying, mass of carbon will remain constant, mass of hydrogen will remain constant. In the beginning you have carbon, hydrogen and oxygen. If I can get the mass of carbon and mass of hydrogen and deduct that from the initial mass of that you will get the oxygen that comes from this specifically, not this oxygen. You understand? Right? Makes sense? So from this you find the mass of carbon, you find the mass of hydrogen from the original value, whatever that was, this value. You don't need, I'm telling you, this is a different tangent. This is not the way to solve it. This is not the way to solve it. What you solve is, you just find the mass of carbon from here, you find the mass of hydrogen from here, and from this value subtract that. Now you have mass of carbon, hydrogen, oxygen, and from there you can just follow the empirical formula method. Okay, should I solve it or will you do? I will. So basically mass of carbon will be how much? Mass of carbon will be it will be 0.286 is mass of CO2. ठीक है, इसको डिवाइड करेंगे तो CO2 के मोल्स आ गए. This is same as moles of carbon, and you multiply by 12. This is mass of carbon. Similarly, mass of hydrogen will be how much? 2 times 0.117 by 18, correct? This is mass of hydrogen, and mass of oxygen will be, what is this value? Let's do this now. This whole thing. इसको कर देते हैं, कुछ कर दिया होगा ना 11. So this is what 286 into 3 is how much? This is what? ठीक है, इसको अभी ऐसे ही छोड़ देते हैं. हाइड्रोजन विल बी हाउ मच? हाँ, पॉइंट, इसको 9 कर देते हैं, 0.117 by 9. So these two values, their mass of oxygen will be what? Minus 0.858 by 11 minus 0.117 by 9. That's it. Now you have all three masses. Smallest sample. No, convert them into moles first. First convert them into moles, then take the smallest, take the simplest ratio. That will give you the answer. Clear? Did you solve this by? Anything else? मेरे को मॉड्यूल दो. तो yesterday कर भी देते हैं, कोई रिवीजन टाइप भी कर देते हैं. We did what? Yesterday we did stoichiometry. Then we did, what else did we do? LR, yes. LR. Limiting reagent, then POC, then percentage yield, percentage purity, है ना? I think these are the things we covered. Any doubt in any of these things? Okay, chalo. Last part of this chapter, concentration terms. Let's get to it. So first is strength of solution, which you can do 4 ways: percentage weight by weight, you can do percentage weight by volume, you can do percentage volume by volume, and you can do percentage volume by weight. Percentage weight by weight will be what? Weight of solute divided by weight of solution into 100. अच्छा देखो, actually इसको start करने से पहले we should have talked a little bit about solution, है ना? What is solution? How did you define solution भाई? चलो उसके बारे में बात कर ही लेते हैं. What is a solution? Define solution for me. Fast. Those are components. So if I mix any two things, it becomes a solution? No. Yes. And it could be any actually. Binary solution is in our syllabus, so we generally talk about two things. Solution can be tertiary, quaternary. मतलब पानी के अंदर तुम चीनी भी डाल सकते हो, नमक भी डाल सकते हो, नींबू भी डाल सकते हो, वही सब चीज डाल सकते हो, कोई दिक्कत नहीं है. The thing is, the idea is the mixture that you're making, that should be a homogeneous mixture. It should be uniform throughout. Only then it is allowed to be called a true solution. Huh? Alloy, yes, they are. They're solid solutions. So we will study there are like 9 types of solutions you can have. Alloys are also solutions, definitely. Anything that is a homogeneous mixture of two or more substance is a solution. That is what solution is, okay? A homogeneous mixture of two or more compound or substances, है ना? And now what we study, because again we are nursery kids, we study very primitive stuff. What we study? We study only binary solution. The simplest there is. The binary solution means what? It's going to have two components. What are those two components? Solute and solvent. How to define which one is solute, which one is solvent? In quantity, if I take 0.1 mole of water and 0.9 mole of ethanol, then water is your solute and ethanol is your solvent. And if you reverse that, you take 0.9 mole of water and 0.1 mole of ethanol, then ethanol is a solvent and water is your, sorry, ethanol is a solute and water is a solvent, है ना? Okay, so with that understanding, weight by weight is what? Weight of solute into 100 upon weight of solution. इसमें एक example भी लिखना. If you have 10% NaOH, what does that mean? If somebody says 10% NaOH weight by weight, what does that mean? That means the way you read this is direct. You don't read it like the formula. You don't read it from the formula. You read it directly. You say 10 gram of NaOH is present in 100 gram of this solution. That's how you read this. Always. है ना? That will simplify things very clearly. So always say, what does this mean? 10 gram of solute in 100 gram of solution. Clear? And same rest of the definitions you write, and write this example also in every single case. For written. Okay, clear? चलो भाई, next is, are you writing? Next is second one, which is molarity. What is molarity? Number of moles of solute per unit volume of solution. But the solution volume must be always in liters. So theoretically, if we want to write, how do we write this? Number of moles of solute present in unit volume, actually not unit volume, present in 1 liter of solution. Very specific. It is represented by capital M. Capital M is what? Unit is capital M, which is what? Mole per liter. Then next one is molality, represented by small m. What is the formula? Same, number of moles of solute divided by mass of solvent, not solution, mass of solvent in kg. Okay, not solution by solvent. Okay, again, if you have to define theoretically, what will we say? We will say number of moles of solute present in 1 kg of solvent, not solution, again solvent. Okay, next, mole fraction represented by, what is this? This is equal to number of moles divided by total moles. So let's say you have a solution in which you have A plus B plus C plus D, then number of mole fraction of A will be how much? It will be Na upon Nb plus Nc by Nd, है ना? Now, with mole fraction there are two things. What is one thing? First thing, X will always be between 0 and 1 for any given solution. What is the second thing? What is the second thing? Second thing is mole fraction of A plus mole fraction of B plus mole fraction of C plus mole fraction of D will be equal to 1. Mole fraction is like X. I don't know how to. X. What happened? हाँ मोलैलिटी, अच्छा मोलैलिटी का यूनिट तो लिखा ही नहीं मैंने. व्हाट विल बी द यूनिट ऑफ दिस? एम. दिस विल बी मोल पर केजी. What will be the unit for mole fraction? Unitless. अच्छा, sometimes na they will give you just as a 10% NaOH solution, and nothing else they will give you. They will not tell you whether it's just weight by weight, weight by volume, volume by weight, volume by volume. Then what do? Assume weight by weight, not volume. Assume weight by weight, है ना? चलो क्वेश्चन लिखो. चलो पहले पीपीएम भी कर देते हैं. चलो एक बार पीपीएम भी कर देते हैं, फिर क्वेश्चन करते हैं. डन. नेक्स्ट इज पीपीएम. पीपीएम इज व्हाट? पार्ट्स पर मिलियन. तो दिस इज फॉर लाइक जो वाटर वगैरह के अंदर मिनरल्स वगैरह प्रेजेंट रहते हैं ना, तो दे आर वेरी वेरी स्मॉल क्वांटिटी. So if you take molarity, these are too bigger a scale for it to be registered. So this is a very small scale. What is the value of this? This is same as weight by weight. So this is equal to weight of solute divided by weight of solution into million. ठीक है भाई. And last term is called normality. You guys know this term? Normality? Huh? Heard about it? Normality is n, and it is number of gram equivalent of solute divided by volume of solution in liters. What is gram equivalent? Gram equivalent is same as moles. So stoichiometry. Stoichiometry says in a given chemical balance, in a given balanced chemical equation, right? Reactants react and form product in their in the ratio of their stoichiometry, है ना? Stoichiometric coefficients. This is new thing. Older thing was what? Older thing was law of gram equivalence, no stoichiometry. Law of gram equivalence. And law of gram equivalence states that one reacting, if A reacting with B producing C and D, then one equivalent of A will react with one equivalent of D and will produce one equivalent of C and one equivalent of D. Very simple. Huh? No, but like in stoichiometry, you say 4 mole react with 2 mole to give. Yes. So that's why this is the newer thing, and it's out there. In the older thing, but the benefit that you get is this. In order to do stoichiometry, you need to actually write the equation, balance the equation. In this, you don't need to write the equation, balance the equation. But they are the thing. You are right. I give it that. What is gram equivalent? Gram equivalent is like mole. What is mole? Given weight upon molar mass. This will be given weight upon equivalent weight. Okay, bhai. How do you find equivalent weight? Equivalent weight is molar mass by n factor. Okay, bhai. How do you find n factor? Okay, by the way, one thing you can write is n factor or वैलेंसी फैक्टर है ना, इसको वैलेंसी फैक्टर भी बोलते हैं. And there are 4 different ways to find it depending upon what you have. Huh? Yes, 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 yes. Yes, yes, absolutely, absolutely, absolutely. So, so okay, let's get into it. Let's get into it. So n factor, how to calculate, bhai, hai na? How to calculate this thing? So how to calculate n factor? So first is for acid and bases. For acid and bases, for acid it is the basicity, meaning number of H plus it has released, not can. Can is not the right word. It has released. अच्छा खाली it has released or can release, चलो ये भी लिख देते हैं. अब depends upon, अगर एक equation दिया है आपको, acid base reaction दिया है, and in that let's say you have H3PO4 and H3PO4 can release 3 acid, and in that as reaction it has only released 1, so you will say n factor is 1. But if they have given you just H3PO4, then you will say n factor is 3. So that's why I have written it has released or can release. Hai na? This is under a reaction. This is under as an isolated compound. Clear? And same way you can write for base. For base it will be acidity, which means number of OH minus ions it has released or can release. Acha. That's it. That's pretty much it. Very straightforward. Except for you have to be careful. You have to be very, very careful. So, for example, I give you H3PO4. I give you HCl. Right n factor hai na fast of these things. Let's say I give you H2SO4. I give you H3PO2. I give you H3SO3. Sorry. H2SO3. I give you H3PO3. I give you H3BO3. कोई नहीं, write. Even if you get wrong, write wrong in your notes. देखो, chemistry again it's about theory. So it's not about only remembering the right, but it's not about eliminating, not making the mistake. Even if you get the right one, wrong answer, keep that in your notes. Huh? Right, whatever it is, right? Tell me, what is how much is this? 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 Both. Write this first. I'll change the slide. Because boron has a vacant orbital. Boron has a vacant orbital. It would rather take. It's the most unique acid that we have. I'll write it. I'll tell you. It's an acid which doesn't release H plus, instead takes OH minus. And bichara water suffers. So first of all about these compound, है ना, H3PO2, H3PO3. So only the hydrogen which is connected to an electronegative atom can be acidic. है ना, phosphorus का electronegativity is 2.1, hydrogen का electronegativity is 2.1, cannot be acidic. है ना, you have to be bonded to an one electronegative atom for that atom to be released and be able to take the negative charge, because when you are removing the H plus, some atom in that molecule is getting that OH negative. है ना? That's why you will see most of the acids that you see, if you pay attention, they are either oxo acids, either they are halo acids, right? Pretty much everything that you can think of will be either an oxo acid or an halo acid. Huh? No matter what it is, you think of it, you think of acids, whatever acids have been known in life, they'll either be halo acids or they will be oxo acids. You won't find anything else. Not negative 18. I'll tell you that book that you guys did not read. There's the, I think, which has million times than that. Million times. That's what I'm saying. You've not read it. You read that book, you'll know. What was it? I forgot. What was your reason for not reading the book? You did? Which one did you read? There's this Gilbert Lewis Cup whole section. I'll tell you the chapter. I'll bring the book someday, and I'll read it there. Never win the Nobel Prize, Gilbert Lewis. Yeah, clear. This part is clear. So basically, you know, this is the thing. These H are present, but they're not acidic H. That's the first thing. Now we come to the infiltrator. Who has infiltrated this community? It shouldn't be here, but is here, and we are all inclusive people. We don't throw people out, so we keep it. But this is the system, है ना? Boron doesn't have complete octet. It has a vacant p orbital. ठीक है? It doesn't have complete vacant orbital, so this acts as what? Something we call Lewis acid. Lewis acid is something that can accept an electron pair. Lewis base is something that can donate an electron pair, है ना? So this actually is a Lewis acid. So when you dilute it in water, or dilute it whatever, make it water, what happens is H plus comes out, but that H plus is actually coming from water. It just takes the OH from water and this H plus comes out. That's why this is one of the very, very weak acids. इसके बहुत सारे far-reaching consequences होते हैं that we will see in different chapters. For example, you cannot do titration for such acid. They are so weak acid. इसको लिख भी लो यहाँ पे, very weak acid. So with these kinds of acid, you can't do titration because you will not get a curve, proper curve to put an indicator in that region, है ना? Indicator को एक straight line का curve चाहिए होता है, a pH range within which it can work. These kind of you can't allow. So we figured out a new way to titrate them, which is called conductometric titration. I don't know whether you've heard it this or not, which we'll do in electrochemistry. So very far-reaching consequences of this. What is the name of this compound? You know, it's called boric acid, or sometimes also known as orthoboric acid. ठीक है भाई. Second, acid हो गया, bases हो गया, दो चीज कवर हो गए. What is left? Third, salt. total number of electrons. Very simple. So basically, which is what? The net charge on cation or net charge on anion. You can also write that. So for example, you have aluminum sulfate. What will be the N factor of the salt? N factor will be 6. And somebody asks you the N factor of aluminum, that will be right. N factor is what? Total number of electron exchange. Na? That you can ask for salt also, you can ask for individual also. So for if you say for salt, how much is that? That is 6. For aluminum, how much that would be? That would be 3. For sulfate, how much that would be? That would be 2. Clear? That is for salts. So acid done, base done, salt done. What left? Everything else. Reagents undergoing Rock sketch. Okay, how much that would be? Delta N factor will be equal to delta oxidation state. Okay. For example, we have KMnO4. So K is spectator ion. I'll take the MnO4 minus. You know this. This is a purple color, violet color compound. You know, if you have ever gone to lab, you must have done some. If one experiment in life you would have done this experiment. Anything else you know not. No, you haven't. Oh, but literally, I think I went to lab one time in my life, and that's the experiment we did. So that's based on that, I'm assuming. But this is a basically purple color compound. Hmm? अच्छा अरे यार अच्छा कॉपर सल्फेट का क्रिस्टलाइजेशन द ब्लू क्रिस्टलाइजेशन okay okay so this is KMnO4 this is purple color violet color whatever you want to call it bhai hai na color aficionado so if you have acidic medium here the oxidation state is +7 here the oxidation state is +2 वैसे तो देखो ये भी एक्सचेंज ऑफ इलेक्ट्रॉन ही है इसका इन फैक्टर क्या हो जाएगा 5 but the same reagent you take in a mildly basic or neutral medium you get MnO2 here the oxidation state is +4 here it is +7 by the way these reactions you're supposed to remember N factor is going to be 3 this is called manganate this is called permanganate okay this is K2MnO4 basically this is green in color what is the N factor here 1 so this is +6 and this is +7 this is Do you know how to find oxidation states? Okay. Hmm? Oh, wait. We slow down. Redox, huh? Right. Right. This is. See? Redox reaction. I don't even know whether this chapter actually has all this or not in this, but if you solve the. Acha, this is redox. Okay. But I think in Narendra Avasthi also. Oh. ऑक्सीडेशन स्टेट भी कर ही दे क्या? व्हाई नॉट? अच्छा एक और कर देते, चलो पहले मैं क्रोमेट का भी एग्जांपल लेता हूँ क्योंकि वो भी तुमको जानना ही पड़ेगा. दिस इज Cr2O7 2 minus. So I remember it like this, by the way. So dichromate is orange. Okay, this is orange in color. Can't remember things, so I have to figure out ways to remember it. This becomes Cr3 plus. Here the oxidation state is +6. This is +3. This is green in color. And the n factor for this would be what? This is +6, this is +3. What is the n factor? No. Hey, yes. N factor will be 6. If somebody asks for chromium, then the n factor is 3. है ना? Dichromate, for dichromate it will be 6. Okay. What is the n factor here? Huh? What is the n factor here, bhai? This is orange, by the way. Sorry, not orange. My bad. Sorry. Yellow. What is the n factor in this reaction? 0. What is the n factor? बताओ भाई. What is the n factor? This is not a redox reaction. You can't find like this. This is +6 +6. No change in oxidation state. This is not the method you will use for this. Even if you have to find out. Understand? This is how will you take that? This is just either you can find for this, you can find for this separately. Not a redox reaction. Clear? Anything else left in this? Yes. What is left? Oxidation state, है ना? चलो भाई. Oxidation number. So what is oxidation number? Oxidation number represents oxidation state. Okay, bhai. Amazing. What is oxidation state? Tell me, bhai, what is oxidation state? Okay. It is the imaginary or real charge present on any atom in a given compound state. So it is the imaginary or real charge present on any atom in a given compound arising from the assumption that more electronegative atom will take the electron. Let's look at these two compounds. Basically, what you do, this is an ionic compound already. This is Na plus, F minus. So this is +1, this is -1. That's the oxidation state. And this is real charge. In case of covalent compounds, there is no real charge. What will you do? You will give the electron pair to more electronegative atom. In that case, it is imaginary charge. This is +1, this is -1. You understand? This is what oxidation state is. That's it. Now, how do we find it? That we'll talk about. Done. Now, in order to find books, it will find sometimes they will say rules to find oxidation state. There are no rules. It's all wishy-washy, है ना? So we say we be smart. We say guidelines. Find oxidation state. So even if we get wrong, we say okay. We never said there were rules. We said this is how you can figure it out. You didn't pay attention. Okay. So guideline to find the oxidation state. So first of few basics. What are the basics? Basics is all like net sum of all oxidation states of all given elements in the molecule or ion will be equal to the net charge on the molecule or the ion. So if you have whatever SO4 to minus, so sum of oxidation state of sulfate and 4 oxygen should be equal to -2. If you have AlCl3, then sum of oxidation state of Al and 3 chlorine should be equal to 0. है ना? That's the first point. Write that. By sum of all oxidation state of the element should be equal to the net charge on the given ion or compound or molecule. That's the first point. Second point is, for any ion, its charge is the oxidation state. ठीक है. Third point, for any element in their elemental state, oxidation state will always be 0. Sir, sir.
आपको क्लास के बाद एक बार क्लास
हाँ हाँ ऊपर
अच्छा वो क्लास फ्री नहीं है आपका उसके बाद
नहीं.
एक्चुअली अमन सर सडनली तो कह
हाँ?
रहे थे अगर हो सके तो इसमें केमिस्ट्री एक्स्ट्रा करवा लो.
पर मेरी दूसरी क्लास है.
अच्छा उधर है क्या?
हाँ
ठीक है मैं राकेश सर को
हाँ. ठीक है भाई. चलो नेक्स्ट पॉइंट लिखते हैं. तीनों और 3 पॉइंट हो गए. तो दिए 3 बेसिक्स है. अब इसके बाद हम एक्चुअल पॉइंट से स्टार्ट करते हैं. इनको तुम कोरोलरी बोल दो या कुछ भी बोल दो. कोरोलरी तो खैर नॉट द राइट वर्ड, व्हाटएवर अलग से बोल दो. पॉइंटर यहाँ से चालू होते हैं. तो फर्स्ट मेन पॉइंटर जो है वो ये है. ये इसको देखो अगेन, है ना, ये एक मेड अप सिस्टम है जो मैंने बनाया. अब you take and you can make your own system, है ना, because again there are no rules to this thing. I have tried to make the one that works for me the best and I'm giving that to you, then you figure out your own, or you can use this. Pretty much what should work, I think. Okay, so first is that there are some elements which have fixed oxidation state, so they make our life the easiest, because once we see them we can just mark them and calculate for something else. So first is fluorine, always -1. Group 1, which is lithium, sodium, potassium, rubidium, cesium, always +1. Fixed oxidation state. Group 2, beryllium. What is after that? Beryllium, magnesium, calcium, strontium, barium, always +2. ठीक है भाई. Aluminium always +3, zinc always +2. So as soon as you see these elements, your life is easy. You can fix them. Second is hydrogen is always +1, except when it is bonded to metal, because if with everything else it is less electronegative, but with metal is more electropositive, so metal will release the electron, it has to take the electron. So H is always +1 except for metal hydrides, or but even yeah, that's the better one. That's the better. Now third point, here is the trick. Oxygen is always -2 except when bonded to 1 and 2. So basically उसके जो नीचे आते जाएंगे ना, इसके नीचे जो हायरार्की आती चली जाएगी, for that it is fixed. The only time it will be variable is when it is bonded to these two. But that's where the good part is, because for these we know the oxidation state, from that we can calculate. So I'll give you two examples, है ना, यहीं पे ले लेते हैं, ये लिखने हैं. Yeah, I will forget. I will forget. Remind me when we finish this. We have to write a fourth point in n factor, which is for disproportionation reaction. है ना? I will 100% forget it because I already forgot it. Written. अब look at this. Find this. See. Find. I'm giving you examples. Find oxidation state of oxygen in all these compounds. है ना? So I'm underlining the atom that you have to find the oxidation state for, है ना? Sorry. This basically oxygen के लिए find करना है हर चीज. Done by. What is the oxidation state here? These you don't need to know nitrogen का oxidation state in order to calculate oxygen का oxidation state here. This is an element which doesn't belong to any of these. This is going to be this. Yeah. And see, so now generally what with books here different you have to remember peroxide. You don't have to remember anything. You can just figure it. All you have to remember is this hierarchy order in which we are going, and from that you can sort it out. ठीक है ना? Clear? Okay. Next is nitrogen. Nitrogen is always what? -3 except 1, 2, 3 and NCl3 because N और chlorine का जो electronegativity है it's too nearby. Chlorine is 3.16, nitrogen is 3.04. Because of that there is an issue. And then fifth, similarly we can say halogens are always -1 except 1, 2, 3. And by the way, this doesn't mean that in this 1, 2, 3, 4 it cannot be -1. It just means that in case of 1, 2, 3, 4 you always find it out. You don't presume it. By the way, halogens mean what? Chlorine, bromine and iodine. Fluorine is not included here. So in 1, 2, 3, 4 we have to find out the oxidation state. It could still be -1. It could still be -1, but we can't presume. For anything else we can presume it, no problem. Okay. Sorry? Yeah, but not when it is bonded with ClF3. Huh? Yes, expected, definitely. So that's why we can write for these, no, like halogen is always expected to be -1, nitrogen always expected to be -3, oxygen always expected to be -2, hydrogen always expected to be +1. No? And the last part, but this covers very small part. Somebody said, "Bhai, I have FeS2, find me." Or FeS2 is not the right. Let's say Fe2S. Some Fe2S is also not right. Okay, Fe2S3. Okay, okay. I'll take something else. Let's take copper sulfide. Somebody says, "Bhai, find this." Yeah, none of the thing that we did is useful here. So what do? So this is very simple. These are much simpler because in this there is not much possibility. So you find the cation anionic part, you check the group number. For example, 16. If the group number is 16, then valency is what? Group 16. So oxidation state will be equal to valency for the anion. So this is then -2. That means this should be +1. That's it. That's how you're going to do for the rest of the elements. Or you're going to find out what the cation is. You can write steps. First, find out what the cation anion is. Find the group number of the anion. That group number will lead to valency. Valency will be equal to oxidation state. And once you have the oxidation state of the anion, you can find the oxidation state of cation. Okay, that's how you're going to calculate oxidation state by. Okay. Fourth, and factor for disproportionation reaction. What is disproportionation reaction, by? Actually, that is not example disposition. What is disposition? No idea? Yes. Yes. S3PO3 will give you S3PO4 plus PH3. Elect. What was I writing? N factor for disproportionation reaction. Same element or compound getting oxidized and reduced simultaneously. So, for example, so here what is to find out? Chalo, use your, you just learned find oxidation state, find out the oxidation states. The oxidation reduction, you understand? Oxidation is loss of electron, reduction is gain of electron, right? मैं लिख देता हूँ, ये भी लिख देता हूँ. Getting oxidized. Oxidized means what? Loss of electrons. Reduced means what? Gain of electron. So what is the oxidation state? Find out of all three places. Clear bhai? So somebody says, bhai, okay, what is the N factor of this reaction, or what is the N factor of HNO2 here? Can you tell me? Without me telling also, this is something you can figure out, but I will obviously make it easier and simpler and organized. But without me having to tell you, you can figure out the N factor of this. Can you try? First you tell me answer, then you explain. Please not the answer. So again, what was the core? Why did we say ki acha, this can be a delta oxidation state? Core is even salt everywhere. If you see, even in acid base, if you go everything core, it's all electron, right? H plus, how many H plus losing? That many electrons, that compound is gaining. So everything is just electrons. So just go by that. What is the N factor? What is N1 is N factor for ऑक्सीडेशन N2 is oxidation factor of reduction. हाँ 10 कहाँ से हुआ? What is the N factor here? 2. This will be 1. So this will be 2 by 3. है ना? So it will directly find out, and you can also find out through this only. No, see, HNO2 becomes HNO3. So ultimately, what is the total idea? How do I understand how many electrons actually, how many electrons actually need? Ki given and take, where however much you're giving and how much you're taking becomes equal, that is the actual number of electrons, right? So if I say for HNO2 to HNO3, what happened here? This was gone from +3 to +5. That means it is releasing 2 electrons. So other one is what? HNO2 becoming NO. This is going from what? +3 to +2 to equate what I need to do. +2 electrons, right? So in fact, how many electrons are being exchanged actually? 2. By total, how many number of molecules? 3. What is the N factor? Okay, it's not like you have to remember the formula. You can figure it out as well. I'm telling you, this whole thing, that at the core is always electron. Yes, that's how you will get. And again, as I said, how much are going and coming? How do you understand them actually? And once you, the moment they are equal, that is the actual thing, because otherwise it can be break down into so many different ways. But the always, if I can have giving and taking equal, that is the actual number. Reduction, है ना? Clear? Or you can directly use the formula. Also, that works. You will not have a problem. Just write this. Here, N factor for this reaction is oxidation half is what? What is the N factor here? 2. This is your N1 value. What is the N factor here? 1. This is your N2 value. So N factor overall will be what? N1 into N2 upon N1 plus N2. This will be what? 1 into 2, 1 plus 2. This will be 2 by 3. Okay? Clear, bhai? Chalo. What do? I explain all the remaining stuff or I leave this? ठीक है, चलो. So normality. Now you understand normality. All this in order to explain normality. Clear? ठीक है, चलो दो छोटी छोटी चीजें मैं बता ही देता हूँ यार, चैप्टर खत्म हो जाएगा, then you can go and do questions at home. So normality is number of gram equivalent by volume. Relationship between molarity and normality you figure out. Actually, this is a homework question, na? Homework question. Second, you figure out relationship between molarity and molality. These two things you got to do homework, hai na? Okay, let's move on. I'll fastly, very very fast, do two things. Volume strength of hydrogen peroxide. Very simple. What is volume strength of hydrogen peroxide? Volume strength of hydrogen peroxide is the amount of O2 liberated. So peroxide breaks down into water and O2. So when you have a peroxide, hydrogen peroxide in a bottle, na, it doesn't say gram per ml or whatever. You will read it. Even if you ever seen alcohol bottle, yeah, if you read beer or whiskey or whatever, like if you have, if you read that, it says volume strength, it will be volume by volume, but and even more chemicals, other chemicals also in lab वगैरह you will see, you will find most of that. But hydrogen peroxide, if you bottle you see, you will never find that. It says volume strength. So what is volume strength? Is completely different. It depends upon the number of, not number, sorry, amount of oxygen you can evolve for a given amount of peroxide. So for example, if this is 1 mole, that means 1 mole in 1 liter. So 1 mole in 1 liter will produce how much? 1 mole of this, 1 mole of this, 1 mole of this is how much? 11.2 liter. Look here once again. This is 11.2 liter. So what is the volume strength of this 1 molar solution? 11.2. Okay. Now if this is the 5 molar solution, this will become how much? 11.2. So what is the formula for volume strength? 11.2 into molarity. And normality, because n factor for this is how much? N factor you can figure out. N factor will be 2. So this will become 11.2 will become 5.6. Clear? That's volume strength for you. I'll send this PDF, you can write this later. Do you understand the concept? Clear? Other concept is, so these are the formulas, you can strength in gram per ml, you will figure this out. These formulas you understand. Okay. Next thing is percentage labeling of oleum. So again, oleum is different labeled. First of all, what is oleum? Have you ever heard this name? H2S2O7. Oleum is H2S2O7, H2S2O7, and if you break it down, it is nothing but H2SO4 with some free amount of SO3. And SO3, if you put H2O in that, you get what? H2SO4. So if you have a oleum ka bottle, it will be labeled in different terms. It will be labeled 118% oleum. Yes. So what does that mean? So if a bottle is labeled 118% oleum, it means that if you add 18 gram of water in this, you will get 118 gram of pure H2SO4. So whatever this, you know, so basically the amount of water that, so 100 plus jo bhi hai na, whatever is in the 100 plus addition, that is the amount of water that you require to react with the entirety of F3SO3 that is present and convert the whole thing into complete H2SO4. So that is how it is written. You understand? So 109 means what? You put 9 gram of water, which that will give you 109 gram of sulfuric acid. Now there are a bunch of questions that arise from it. So somebody might ask, okay, I have a 109 gram oleum solution. How much free SO3 is present in that? Very easy to figure out. How much water am I adding? 9 gram. So 1 mole of H2O reacts with 1 mole of SO3. So half mole if I have, half mole of SO3 I have. So whatever is the mass, molar mass of SO3 divided by 2. Clear? So these are the two concepts. This chapter is over. You can solve everything. This PPT I'll send in the group. You write these two things. Okay? Monday I'll bring a paper of atomic structure. We will do the class.